Smart charging is very interesting because we see an increase in renewable production, and we see an increase in the use of electric vehicles in the Netherlands. And right now this is not a big problem, but in the future the mismatch between supply and demand will increase due to these trends. And I see smart charging as one of the perfect synergies between those two to come up with storage capacity to use the electric vehicles to store the renewable energy and use it for later times in our electricity network.
I think most of you know that we see an increase in renewable production, for instance, production of solar energy and the installation of solar panels. And we also see an increase in the use of electric vehicles. Now, that's very nice, but the problem is that drivers of electric vehicles don't always charge when the sun shines. And the electricity is available when the sun shines, as you see in this figure. And this is causing electricity prices to vary a lot throughout the day, and this will only increase the coming decades. When there's a lot of sun available, we see low electricity prices. When there is a lot of demand for electric vehicles, we see high prices in the morning and the late afternoon. And in Germany, you already experienced this much more than in the Netherlands. And we can use smart charging to charge our electric vehicles in times that there is a lot of renewable energy abundant. And then we can balance supply and demand and reduce this fluctuation in electricity prices. So why would we do this? Firstly, because we drive more sustainable. Secondly, because we charge cheaper. And thirdly, because we create a more cost-effective electricity network. My name is Michiel van Lelyveld, and I finished my master's in energy science. And this is where I wrote my thesis about at ELAD.nl. And I implemented smart charging in the Spark City model. I have a background in physics, and I did research in demand response and energy markets before. That's why this subject was perfect for me. And I will be moving to Barcelona in 2 days. The city of electric vehicles, as they call themselves. They have electric taxis, as you can see in the figure. And I will be working on the Spark City model more in Barcelona. And I think this is a perfect example of flexible working opportunities that we have as young people. We need a laptop and internet, and we can work anywhere we want. And I'm very excited to work on the model. In this presentation, I will give you some examples of things we can analyze with the smart charging module and the Spark City model. In the second part, I will talk a little bit about the approach of modeling, and I will end with some things that we can implement after today. So let's take a look at some example scenarios. I raised 4 stakeholder questions to give you a feeling of what type of questions we can answer. We have maybe an energy supplier that wants to know how much load we can shift throughout the day with smart charging, because they want to balance their portfolio, so flexible load is interesting for them to balance their portfolio. We have a grid operator that wants to know what the impact of charging is in a local network, because they want to avoid load peaks. We have an EV user that wants to charge the cheapest as possible, so smart charging can reduce the charging cost. And lastly, we have the government that wants to reach certain climate goals, and smart charging can increase the amount of renewable energy that we charge. So for the first 2 stakeholder questions, we can take a look at these results, which represent the load on the local grid. And you see the gray area is the average load of 200 households of the Zeeheldenkwartier that we simulated in this simulation. And we add 5% of EVs in that neighborhood, and you can see the impact of the EVs in the colored areas. And the red area is the impact with normal charging, and the green area is the impact with smart charging. And this is on average per day. Now you can see that nearly all the load is shifted from the late afternoon to midnight with smart charging, which indicates that there is an enormous flexibility in this charging load. If we increase the EVs to 20% in the neighborhood, we see that the impact on the local grid is increasing, but we can still shift most of the load to different time frames. What you can also see for grid operators is that the big peak in the late afternoon with normal charging can be reduced if we apply smart charging to charge our electric vehicles during the night. It's also interesting to see what the impact is on a national level. So here we have a graph that shows the average national electricity demand of the Netherlands. And you can see what impact 20% of EVs in the Netherlands will have on our national electricity demand. And again, you see that smart charging is shifting this load. With 20% EVs, it's not such a big influence, but if we have at one moment 100% of EVs, then you can see what impact electric vehicles have on our network or our electricity demand, and how we can use smart charging to really make this demand more flexible. So we can adjust to more renewable energy, for instance. Now, one of the important parts of my research was to see what the impact is of this kind of demand response or smart charging technologies on electricity prices. This is why I want to show you this graph where the prices are simulated in both the case of normal charging and the case of smart charging. The red line is in the case of normal charging. You can see how the prices are varying much more throughout the day with normal charging. This is, by the way, with 20% EVs in the neighborhood. And you can see that the peak prices are increasing. The average price is also increasing. And if you apply smart charging, you can see that the electricity prices are much more balanced throughout the day. You can only see a slight increase in prices during the night. And this indicates that we can make our electricity system more cost-effective with smart charging. Here we see the 1 month of simulation of charging cost, electricity cost for charging cars. And in the baseline scenario, which is without smart charging, the cost is always higher than with smart charging because we charge when prices are low. On average, over 1 month, we get 38% cost savings. This is kind of an average estimation. If you put in different neighborhoods, different driving behavior, whatever, you get in between the 30 and the 40% savings, which means around 7 euros per EV per month. So for instance, if you have an electricity supplier that uses smart charging to reduce charging cost or electricity cost, you can give a discount to your consumer of 7 euro per EV per month. Now let's take a look at the amount of renewable energy that we can charge with smart charging. This graph shows you the percentage of renewable charged electricity per generator. You see that wind energy is charged more when smart charging is applied, and we get a total increase of 18% renewable energy if we apply smart charging compared to normal charging. We see also that the PV is actually decreasing slightly. This is because of a little glitch in the driving behavior right now, because commuters stop charging during work hours for some reason, which means that there are less commuters charging during the day when the sun shines. So less PV is charged. I believe if we solve this issue, we actually can increase the amount of PV that is charged with smart charging. I want to fix that bug, but we have to wait for the results. So those were some of the example results that I can generate with the smart charging module. Now a little bit about the modeling approach. I don't want to go in depth, but to give you an idea of what I did. Here you see the smart charging module connected to the Spark City neighborhood. And the smart charging module is built out of 3 boxes. First, I simulate spot market prices. Second, I enable smart charging in the neighborhood by connecting with the charge points. And thirdly, I translate the electricity demand of the charge points into spot market demand shift. So we can see the influence of charging on spot market prices. And this is one of the feedback loops that we can build in agent-based models, as you heard before. For pricing, I used merit order matching in 2-sided auction systems for the people who know what I'm talking about. I'm not going into detail, but I did also a validation on two different supply curves that I created for the merit order. And the first one, I used data from ECN, one of the Dutch institutes on energy research. And I was not very happy with the results because, as you can see, the orange graph is not really the same as the black curve, which represents the average APX prices of 2016. APX is the biggest spot market in the Netherlands for trading electricity. And then I came up with a second method, which actually was very satisfying, and I want to improve on this method even more. For smart charging, I used a technique referred to as valley filling. I always choose the cheapest hour to charge, and the charge is finished when either the car is plugged out or the charge needs are fulfilled. And it's in iterative steps. Some of you might know what this is programmed like, but yeah. So last thing I want to talk about is what's next. There are three things that I want to discuss. First thing is, right now, the smart charging is not including local grid constraints. And it would be very interesting for grid operators to include those local grid constraints because you can use smart charging, but at least you have to know, is it inside the local grid constraints? Secondly, I can improve pricing with new and better renewable generation data that I have available right now. And the third thing is improving the driving behavior, which refers to the glitch where I was talking about. So there are some small things in the driving behavior that are happening right now that are influencing the results slightly, and they can be made a little bit better. So I believe that right now there is a slight mismatch between renewable generation and electric vehicles, but I believe that they can be a very powerful combination with smart charging in the future. Thank you.